Hey kiddos. All right, so here I am going to jump into lesson 12 in module 2. And there's really no new stuff as far as notes go, so I'm not going to have a page of those for you to copy. It's all the same thing. We're multiplying with decimal fractions. This time, as you can see, we're going to be working with numbers that maybe aren't as easily rounded to a whole number. And what happens if I have 21 hundredths that are repeated a whole bunch of times? And so what does that amount to? So it's just kind of like how to estimate, but then also what all these estimates will get you. And just to make you more aware of if you're going to end up with an overestimate or an underestimate, or how can I get my estimate to be better and closer to my actual final answer. So yeah, lesson 12, reason about the product of a whole number and a decimal with hundredths using place value understanding and estimation. So first we're going to estimate. So let's take this 1.21 or 1 and 21 hundredths times 14. And as you can see, I have a whole bunch of options here. So some kids will say, well, let's take this 1 and just make it 1. I think making it a 1 is perfectly fine. But then that's where it really can be full of options. Some people might say, let's leave it at 14 because 1 times 14 is 14, and that's pretty close to what I originally am multiplying. If you bump this down to a 10 and you've bumped this down also, this is going to be a gross underestimate. If you bump this down to 1 and bump this up, then you're probably a little bit closer to the actual answer, so 15. And again, you can look at what our three options are here just using the 1 times these and compare it with our actual product over here. So if you know that using the standard algorithm, I'm going to get 16.94 or 16 and 94 hundredths, then you can see if the answer is over 16, then 14, 10, and 15 are all underestimates. So how can you make it closer? Well, what if I left this, instead of changing it to a 1.0, what if I left it at 1.2, which is like 12 tenths or 120 hundredths? So then you're talking about, potentially having a little bit of a closer estimate, but you also might have a little bit more complicated figuring in your head, and I'm not about complicated figuring in my head, so I just want to make it super easy. So all this estimating aside, which you can really end up with any of these, but you're only required to have one, then the easy part might be just doing 1 times 14 and ending up with 14. Probably the best guess. Now, really, I'm just writing this here so you can remember that this is hundredths. Pretend like you're multiplying without the decimal. A couple students were putting the decimal in here, and I was like, no, don't do it. Just leave it out and put it back in at the end. You don't need to label it if you put the decimal in, because this is 16 and 94 hundredths. I'm just putting it here so you recognize that's what it is. But this is the final answer in standard form. And then just to multiply, 4 times 1 is 4, 4 times 2 is 8, 4 times 1 is 4. Hold the 0. 1 times 1 is 1, 1 times 2 is 2, 1 times 1 is 1. Okay, that's there, and then you add, and that's how you get your answer. Okay, today we're just going to look through the completed answer book because of all the options with the estimation. Now on this one, again, you have so many different choices, and I'll kind of show you what happens. So let's take this 2, and it's almost 2.5. It's almost 2.5 because 45, remember that vertical number line that we had so much fun with? 45 would be just under 50. And so if you wanted to make it 2.5, that's really very close. 3 is pretty far. 2 is pretty far down. So really the closest estimate would be to keep this at 25, change this to 300, think about 25 times 3 gives you 75, and then kind of shoot for that. You really want to end up with something that's going to be a reasonable estimate. If I was to use 3, say I bump that all the way up and bump this down, I'm going to have a pretty high estimate of 900. But again, these are all close. And you don't have to have all these. You just pick one. But whatever you picked, hopefully it was one of these. Now the book always has different recommendations like the answer key, but I like to accept lots of these and then have students kind of justify why. And then of course, having this here isn't necessarily rounding that number out, but some kids will say, well, I can do that because of the 2 times the 5 and the 10, and then the 2 times 3 is 6, and so they kind of know what it's going to be. So I don't want to stop you if that's the way you think. Just kind of let you know, hey, you got a lot of options here. And anytime they say estimate in the directions, kids are going to come in with different answers every single day. So 5 times 5 is 25, carry the 2. 5 times 4 is 20, plus 2 is 22, carry the 2. 5 times 2 is 10, plus 2 is 12. First partial product, 1, 2, 2, 5. Then this is the ghost 0. This is for the tens, 0, tens. Move over. Don't have a row of zeros. It's just a waste of time. Then we have 3 hundredths. 3 times 5 is 15. 5 goes down, 1 goes up. 3 times 4 is 12, plus 1 is 13. Carry the 1. 3 times 2 is 6, plus 1 is 7. 7, 3, 5, 0, 0. Don't forget the zeros. Still have students forgetting these. I'm sure others are too, but don't forget them. It's vital. Otherwise, you won't have your numbers lined up correctly. 5 comes down, 2 comes down. 2 plus 5 is 7. 3 plus 1 is 4, then the 7. And then you have to think about how many places are there to the right of the decimal. This is hundredths, like it was at the top. It's hundredths. If it's hundredths here, it's got to be hundredths here. Yesterday, or in lesson 11, we're talking about multiply by 100 to get the decimal out, divide by 100 to put the decimal back. You just have to remember to do that so that you'll get the answer right. Okay? Next page, lots of work. Let's just start at the top. Okay. Estimate, then solve using the standard algorithm. Use a separate sheet to draw the area model if it helps you. I don't have any area models. It just seems to clutter up my pages. So again, it's like, how do you want to estimate this? And what would be easiest to work with? Remember, we're just trying to get in the ballpark. If you happen to know that 12 times 12 is 144, and you want to go ahead and do that, I'm not going to stop you. It's just a matter of where do you put the decimal? Well, remember, if I have 2 places here, I should have 2 places over here. This would have a 0 on that one. Then 1 times 12, this is just really a whole number. 1 times 12 ones equals 12 ones. And so just be really careful with where you place the decimal. Then take your standard algorithm, 1.23 times 12. This is hundredths times ones, so my answer should be in hundredths. Old-fashioned way, 1, 2 places, 1, 2 places. 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2. Hold this place with a 0, we're done with the ones. 1 times 3 is 3, 1 times 2 is 2, 1 times 1 is 1, and it's really 10 times 123 for 1,230, but we're talking about hundredths here. So your final answer after you add to nothing, you have your 2 places to the right, so we have hundredths here and hundredths here. Pretty straightforward, I'm thinking. Next estimate, change the 1.3 to 1. 26 could round to 30, but if it's 1, you could really do 1 times 26, and that would be okay. And again, this is an underestimate because 26 being multiplied by 1, we've lost that 3/10 26 times. So 26 times 1.3, and then, another thing I wanted to talk about was if you flip the order. Okay, so today we were working on a sample problem, a little quiz, and I said, here, solve this problem, and it was much like this one. And when I was checking the partial products, it was not exactly working out the same. So sometimes you're going to have really good luck, and other times you won't. Let's see if I can find that for you real quickly. It's probably on this one. So this is the example I'm talking about, if you change the order of your factors, it will change the partial products. So today I said, hey, let's do a little quiz, 3.5 times 46. So of course, I wrote it this way. And I was having students check 35 tenths times 46. And I was looking, I said, hold up your work to the camera. I want to see 210, 1400, and then 1610 tenths, and then the standard form like this. This is what I was looking for. Sure enough, kids are showing me this, and I'm like, oh no, they got it wrong, and I wasn't even looking up here. And then I finally figured out, oh my gosh, they reversed the order of the factors. So it really kind of depends on what you're multiplying as to what your partial products will be. But notice that the answer is the same on both of these because you can change the order. This is that whole commutative property. Switch the order of the factors and you're still going to get the same answer. So that was a problem that happened today. Now this one, if I have 13 tenths times 26, if I switch the order, 3 times 6 is 18, carry the 1, 3 times 2 is 6 plus 1 is 7, and then hold the spot with the 0, 1 times 6 is 6, 1 times 2 is 2. These are my partial products, and I get my final product here. So if I switch the order, 6 times 3 is 18, 6 times 1 is 6 plus 1 is 7, it just so happens that we get the same here. So it doesn't always work out that you have different partial products like on my quiz today, but most of the time they will be different. This is just one of those lucky ones. Okay, so I almost said, are there any questions? Sad there's nobody here. Nobody here to ask questions. Okay, next one, 0.23 or 23 hundredths times 14. Again, you can't change it to 0 because then your answer would be 0, although these are all pretty close to 0. So you have to give yourself something to work with. So try to keep it with like 2 tenths. That's probably the easiest. And then 2 times 15 is 30, but again, you got to be really careful with where you place the decimal in your estimate even. Let's say you don't change the 14 to 15 and you just leave it alone, then 2 times 14 is 28. So do the actual multiplication. 4 times 3 is 12, carry the 1, 4 times 2 is 8, plus 1 is 9, and 4 times 0 is 0, which you don't actually have to do, but if you want to, just because, you can certainly do that. This is your ghost 0 holding that place because we're moving over to the tens position. 1 times 3 is 3, 1 times 2 is 2, and again, you don't need the 0 there, but you can put it there if it makes you feel happy. And how do you place your decimal? 1, 2 places here because this is hundredths. Therefore, 1, 2 places here because it has to be in hundredths. Anytime you have hundredths times ones, you will get hundredths. Okay, next one. 45 hundredths times 26. The closest rounded point would be the 0.5, or 5 tenths, which is equal to half. So we're really trying to get half of 26. So your answer should be somewhere around 13, and that's just doing that in your head. If you leave 26 alone, you would have about 13. But you can change it to 25 because 26 is, a little bit different. Most people will try to get a 10 or a 5 or the next 10 up. So either way, it's totally fine. Remember, you have options when you're estimating. It does not have to be exactly like mine. But the actual multiplication should be. And yes, you can switch the order of these, but you wouldn't want to have the 0 hanging out. I always like the bigger number on top. So 6 times 5 is 30, carry the 3. Then 24 plus 3 is 27, carry the 2, it falls down. Goes to 0. 2 times 5 is 10. This is the 0 from the 10. Carry the 1. 2 times 4 is 8, plus 1 is 9. And then, of course, 0, and you don't have to put it out here because it just doesn't mean anything. 0 comes down, 7, and 11. Then what about the decimal? 1, 2 places, hundredths times 1 makes hundredths. So 2 places there. Next one. 7, just drop that right off, times, you could go to 30 very easily. That would be just fine. Okay. or you could go down to 25, and it's totally up to you. So 7.06 times 28, do the actual multiplication. When you have a 0, it's nice and easy. 6 times 8 is 48, it just falls right down. 8 times 7 is 56, and there's nothing at the end, so that comes down to 0. 2 times 6 is 12, it comes right down. 2 times 7 is 14. Add 8, 6, 7, 9, 1, decimal. 1, 2, 1, 2. Hundredths times ones is hundredths. Next one. Yeah, you could just drop that 0.32 right off. And if you go down to 200, you could go up to 250. It's totally up to you, whatever makes you happy. And it would, both of those would be pretty easy to multiply by 6. So here we have 6 times 2 for 12 plus the 2 zeros. 6.32 times 223 means I'm going to have a 3-part partial product. Okay? 3 times 2 is 6, 3 times 3 is 9, 3 times 6 is 18. 1896. Second row. This is for the ones place because now I have 2 tens. 2 tens times 2 is 40. Now use that 2. 2 times 3 is 6. 2 times 6 is 12. And so it's 20 times 632. Yes, 12,640. Now hold this spot with a 0 for the ones. Hold this spot with a 0 for the tens. And start here in the hundredths place. In row 3. In the hundredths place. Ones, tens, hundreds. 2 times 2 is 4. 2 times 3 is 6. 2 times 6 is 12. And we're done with our partial products. 6 comes down. 9 plus 4 is 13. Carry that little 1 there. 6 and 4 is 10. Then 18. Then 19. 9 down. 1 up. 4 right here. 6, 7, 8, 9, 10. 0. Carry. 2, 3, 4. 4. Nothing to carry. And 1. All in a row. Hundredths here. Hundredths here. Because this is ones. Hundredths times ones equals hundredths. Last one's on this page before we get to the next page. It's a big assignment. 7, just drop off that little bit there and just drop off that little bit. Easy estimating on that one. 7.06 times 208. 6 times 8 is 48. Again, with a 0, it just falls right down. 7 times 8 is 56, and we did that one up here somewhere. So very similar to this number. It is the same. It's just they just have an additional 0. And okay, on the bottom, so hold this place for the ones. Now we have a 0 in the tens place. You get to hold that place. Move over to the hundreds and start multiplying. 2 times 6, 12. 1 comes down. 2 times 7 is 14. So you have all the same digits, 5, 6, 4, 8 up here. 1, 4, 1, 2, 0, 1, 4, 1, 2, 0, 0 because of the 0. See? Look. That's your factors. And because this is hundredths times ones, we get hundredths here. And it's real close. Again, your estimate, the whole point of the estimate is to get as close as you can to the actual answer so that you know that you're not a full place value position off. Okay, here we have kind of a big one, and it's right in the middle. So can you go up or can you go down, or what do you want to do? Well, again, it's up to you, and everybody's going to go a different direction. Some kids will say, well, it's over 50, so let's round up to 200. And then they'll say, well, this is also over 50, so we'll go up to 600. But other kids will say, well, if I went up 50, can I go down 50? And I'll say, sure. It's really up to you in your estimate and how close you're going to get. So here's the actual multiplication, and we have 3 digits, which is going to give us 3 lines. And if you notice that 555, they're all the same, look at what happens to your partial products. Once you do that, that first times 1, you're just repeating all that multiplication, but you're bumping it over. So let's check it out. 5 times 6 is 30, carry the 3. 5 times 4 is 20, plus 3 is 23, carry the 2. 5 times 1 is 5, plus 2 is 7. 5 times 5 is 25, carry the 2. 5 times 1 is 5, plus 2 is 7. So your first partial product is 75730. Okay? Now, I'm done with that one. So I go to the second partial product. Whoop, right here at the 5 tens. Okay, So this is holding the spot here. And this is the exact same partial product, but it's 10 times greater because it's in one place value position over. I mean, I could go through the whole thing and tell you all about it, but it's just exactly the same. Okay, 5 times 6 is 30. Here's the 0. Here's the 3. 5 times 4 is 20 plus 3 is 23. Here's the 3. Carry the 2. 5 plus 2 is 7. And then 25. And then there's a 7. It's just going to be the same. Now this one, this is for the 1s. This is for the 10s. These are just the placeholders. Here's your partial product again, 75730. So if you have a number like this, yes, you can just copy it, but of course I would hope that this one is right before you start copying. Anyway, add those and here's what you get. And let's go on to the word problems so we can have a happy day. Denise walks on the beach every afternoon. In the month of July, she walked 3 45 miles each day. Nice. How far did Denise walk during the month of July? A lot of kids will say, how many days are in the month of July? They just don't know, but it's 31. And 3 45 miles each day. So if you do your standard algorithm, and this is an actual how far did Denise walk, so we don't need to estimate it all. And then you go ahead and 1 times 5 is 5, 1 times 4 is 4, 1 times 3 is 3, hold this place with a 0, 3 times 5 is 15, 3 times 4 is 12, plus 1 is 13, carry that, 9 plus 1 is 10. Add, boop, boop. And then hundredths here times ones makes hundredths. Label everything. Next one. Gallon of gas costs $4.34. Greg puts 12 gallons of gas in his car. Look, step 1. Okay, here's what it's going to cost. $4.34 times 12. He has a $50 bill. Tell how much money Greg will have left or how much more money he will need. So this is a does he have enough money with $50. So figure out what it costs, $4.34 per gallon times 12 gallons. 2 times 4 is 8, 2 times 3 is 6, 2 times 4 is 8. Hold this spot with a 0. 1 times 4 is 4, 1 times 3 is 3, 1 times 4 is 4. Add 5208. Gosh, that was the cost of the gas. So how much money will he need? Well, he's going to need $2.08. I can look at that and say $50 plus 208 would be this. Or I could do the subtraction to find the difference and take 5208 minus 50. This is what it cost. This is what he has. 208 is what he needs. Okay, so just looking at that and comparing. And finally, for the last problem, Seth drinks a glass of orange juice every day. Oh, and then I think we've had lots of discussions about this one. The glass of orange juice contains 6/10 grams of vitamin C. He eats a serving of strawberries for a snack after school every day that contains 35 grams of vitamin C. How many grams of vitamin C does Seth consume in 3 weeks? So you want to think about the orange juice individually, the strawberries individually, and it's all right here. Okay, and so we have the 3 weeks. I think students were confused about how many days. Was it the school days or was it the weekdays? And we said 7 was going to be the answer to that one. So 7 times 3 is 21 days, and that's where we're getting our times 21. If you have your 21 times 6/10, and you have your 0 down here, you only have to have one partial product. So, or one product. 6 times 1 is 6, 6 times 2 is 12. If you flip it around and have the 21 on the bottom, you have to have 2 partial products and add it up. So that's kind of a hassle, so don't do it that way. If the strawberries have 35 hundredths, you still have to multiply it by 21. 1 times 35 is 35. hold the spot with a 0. 2 times 5 is 10. Carry the 1. 6 plus 1 is 7. Add. There's your 7. But also, it's 35 hundredths. Put your decimal in. Also put your decimal here. Forgot to say that. 7.35. So this is the 12.6. Now watch out. In multiplying, we don't line up the decimals. So far you haven't had multiple decimals per problem. But in addition, you must line up. Remember the decimal down, okay? That has to be done here. So you're putting together all of the grams of vitamin C from the strawberries and the orange juice over the course of 21 days. So you have to add and line up the decimals. Let's see. For this one, I think we put together, this was the do it this way. Add up the daily and then multiply that by 21. And this, you are certainly welcome to do it that way. And I always will have lots of students, well, I did it this way. And I'll say, great. That just shows me that you're thinking. And there are many different ways to do these problems. So I hope this is helpful. Have a great weekend. Bye.